Hello and welcome to Year 3's Maths Lesson 14, to subtract fractions. Let's start by warming up our maths brains. Pause the video and have a go at the next 4 questions. Let's look at the answers. Descending order means largest to smallest. 11/15, 8/15, 2/15. Comparing the fractions, the numerators are both the same with 1, so we look at the denominator. The smaller the denominator, the larger the fraction. Calculating 3/4 of 84. 84 shared by 4 equal parts is 21, and 3 of those parts is 63. 23 multiplied by 4 equals 92. So let's have a look at today's lesson. Here's the first question. Amir has 3/5 of a roll of ribbon. He cuts 2/5 of the roll off. What fraction of the roll does he have left? I'm thinking a bar model will help. So here we have a bar model which is split into 5 equal parts to represent fifths. Amir has 3/5 of a roll of ribbon. So we have shaded in 3 of the 5 parts. He cuts 2/5 of the roll off. I have shown this by crossing out 2 of the 3 shaded squares. 3/5 subtract 2/5 equals 1/5. We call this subtraction by reduction. We are taking something away. Pause the video here and have a go at this question. Ron has 5/8 of a bottle of water. He drinks 3/8 of the bottle. What fraction of the bottle is left? I'm thinking a bar model will help. So here's the answer. My bar model is split into 8 equal parts. I shaded in the 5 parts that Ron had, 5/8. He drank 3/8, so I crossed off 3. 5/8 take away 3/8 and it equals 2/8. But did you simplify the fraction? 2/8 is the same as 1/4. So just like in the previous lesson, if you have 5 bananas and you subtract 3 bananas, you're left with 2 bananas. Therefore, 5/8 take away 3/8 equals 2/8. The denominator stays the same. So now let's have a go at questions 1 to 3. Pause the video on each of the questions and then we will look at the answers. Question number 1. Complete the subtractions. Use these bar models to help you. Question number 2. Jack has 7/8 of a chocolate bar. He eats 4/8 of the chocolate bar. What fraction of the chocolate bar does he have left? Remember to use a bar model to help. Question number 3. Complete these subtractions. Remember, you can simplify your answers where possible. Now let's go through the answers. Remember to correct any mistakes you may have made. So here are the answers to questions number 1. A, 1/3, B, 1/5, C, 2/5, and D, 3/5. So question number 2. If you drew a bar model, you will have 8 parts. 7 of those parts will be shaded. Then cross out 4 of those parts to show what Jack has eaten, and you will have been left with 3 of the parts, equaling 3/8 of the chocolate bar left. Answers to question number 3. A, 6/10, B, 5/10, C, 4/10, D, 4/12, E, 4/12, F, 4/12, G, 4/59, and H, 4/127. Some of those answers could be simplified. Go back and check your answers. Let's look at this question. 5/8 of the people in a crowd at a concert are children. 3/8 are boys. What fraction are girls? This is known as subtraction by partitioning. we're going to use a part-part whole model, and we can see that the whole is 5/8. We know that 3/8 are boys. We need to find out how many are girls. So using the bar model to represent 5/8, I have taken 3/8 and put it into the part representing boys. That left 2/8 to represent the girls. We can see that this is subtraction by partitioning. The two parts, 3/8 and 2/8, equal the whole 5/8. Let's look at this question. 5/8 of the people in a crowd at a concert are children. The fraction that are boys has a missing numerator, and we want to know what fraction are girls. Pause the video while you have a go at all the different combinations. I have started you off with this one. If the fraction that are boys is 1/8, the girls must be 4/8. 1/8 and 4/8 make 5/8. Did you manage to find the rest of the combinations? Great job. Did you notice that the numerator in each of the parts of the part-part whole model add together to make the whole? So from each part, the numerators will add to make 5. Now let's have a go at questions 4 and 5. Pause the video on each of the slides while you have a go. Then we'll go through the answers. Question number 4. Complete the part whole models. Question 5. Complete the part whole model in 4 different ways. You can see here that the numerators are missing in some of the boxes. Can you think of the different combinations? Answers to number 4. You can see that both parts that make up 4/5 are 3/5 and 1/5. B. The parts that make up 4/9 is 1/9 and 3/9. C. The parts that make up 7/9 are 4/9 and 3/9. Answers to number 5. You can see here that if we have 4/8, the two parts must be 3/8 and 1/8. If it's 5/8, the two parts must be 3/8 and 2/8. If it's 6/8, it must be 3/8 and 3/8. 7/8, it will be 3/8 and 4/8. This question is subtraction by finding the difference or comparing. Ron and Ava have the same amount of sweets. Ron eats 4/5 and Ava eats 2/5. We want to know how much Ron eats more than Ava. The bar models show Ron eating 4/5 and Ava eating 2/5. The difference is the red arrow, and Ron eats 2/5 more than Ava. Jack and Alex are running a race. Jack has run 4/9 of the distance and Alex has completed 7/9 of the distance. How much further has Alex run? Pause the video here while you have a go. Remember to use bar modelling to show how much of the distance Jack and Alex has run. Here we can see that Alex has run 4/9 of the distance and Alex has run 7/9 of the distance. We can see by the red arrows that Alex has run 3/9 further than Jack. But can you simplify 3/9? That's right, 3/9 is equivalent to 1/3. Now have a go at question 6. Pause the video and then we'll go through the answers. Question 6. Kim has read 6/7 of her book and Tom has read 2/7 of his book. Shade in the bar model to represent this information and then compare. How much more has Kim read than Tom? Pause the video while you complete this. Let's check your answer. So we shaded in 6 of the 7 parts to represent Kim and 2 of the 7 parts to represent Tom. Then we compared these two bar models And we can see that Kim has read 4/7 more of her book than Tom. This is what we call a balanced equation. Both sides of the equal sign must be the same and balanced. 3/7 add 2/7 must equal 6/7 subtract something. I've used two bar models here. 3/7 and 2/7 we can see on top equals 5/7. But what must we do to the bottom bar model to make sure that it's balanced? Well, we can see that we need to subtract one of the sevenths to make each of the bar models the same. Therefore, 3/7 add 2/7 equals 6/7 subtract 1/7. Here's one for you to have a go. Look at this balanced equation. One of the numbers is missing. Remember that each of the sides of the equal sign must be balanced. Can you use a bar model to work out what the missing number will be? Pause the video while you have a go. So let's look at the answer. Does your bar models look like mine? We can see the bottom bar model shows 9/9 subtract 3/9, and we see that that leaves 6/9. The top bar model shows the 2/9 add the 1/9, and we now know that the missing number must be 3 for 3/9. Now let's have a go at the last and final question, question number 7. Pause the video on the next slide while you have a go, and then we'll look at the answers. Number 7. Have a look at these balanced equation questions. Remember to draw bar models to help you. Here are the answers. Make sure you do your corrections. So here is the answer to question number 7. Remember to pause the video while you check your answers. That's great work, day year 3. Remember to email me your work and I can give you some dojos. Stay at home and stay alert. See you soon.